Hello everyone, welcome to Handmade Hero, show where we code a complete game live on stream. I am in the mood to stream and I had some extra time, so I figured I would. This was not an announced stream. It's just a totally unannounced day 507. And I thought maybe what I'd do is just take a break here since this wasn't an announced stream and take a look at all the stuff we've got on our issue list here, because there's a bunch of things that are just little, tiny stuff that we probably will never get to if we don't actually spend some time looking at the issue list and fixing things. So I don't know, I thought that might be a good time to actually go in and set aside an hour or two for fixing some of these things. And also, I guess at the moment too, we should double check to make sure sine and cosine are the only things we actually need for moving off the C runtime library. I was thinking we should move off the C runtime library because we don't need it for anything except sine and cosine, and we kind of know what we need to do to replace those. So that was another thing I was thinking of doing, although that's probably better saved for like a weekend where we can do 2 days of work on that, because it's a little involved to do that replacement, going through the math and all that stuff. Anyway, just looking at some of the stuff here, I want to go back to the earliest things and just see what's up. Go through these sort of issues that have been here. So some of the shots are maybe have the wrong Z set to them in our cutscenes. I don't know if that's true or not anymore, but we can certainly take a look and see. If you remember, the way we do the cutscenes is we just had a list of the plates that were involved in the cutscene, and we just run through them. And so if we jump into this sort of, for lack of a better term, blank screen where we're going to put a title screen someday, if we let this sit, it'll go into the cutscene. That's what we're looking at here. And as far as I know, we've kept this working all throughout all of our changes to like the renderer and the asset system and everything. So these all work just fine. But the question is, do any of them need modifications for Z, like things that might be set Z wrong? And well, there's a thing that's got kind of a weirdness to it. So that's wrong. Whatever that is going on back there, that's incorrect. So that's may not have been anything to do with what they were talking about for that bug, but we got to fix that. You can't see the old plate there. What's weird about that is a lot of these other ones still seem correct. It's kind of weird that we only had one error there, but again, maybe that has something to do with the Z. Maybe we're just only seeing that Z problem, so maybe this bug is accurate. But just looking through these, I'm not really seeing any other errors other than that one. This looks fine, and Santa's doing his thing here, putting it on the little guy. That all looks fine too. So this all looks pretty reasonable, nothing bizarre going on. So it's really just that one cutscene, the middle one there with that second scene. It looks like some of our plates are not working properly like they should have been. Oh, wow. Okay, that's crazy. Oh, you know what, though? This is actually pretty good. This is presumably the texture transfer bug that we were having that's kind of intermittent. That looks the same as the problem we were having before. So we don't really know what's going on there, and we kind of have to figure out whether we're getting a thread stepping on two threads stepping on each other, or something thinking it's done loading when it's not done loading. We don't know what's going on there. Unfortunately, that's probably intermittent. It probably doesn't happen every time, so that we're still waiting for a way to get a good repro on that one. But so I wonder if that's what happened in the second one as well. I'm not sure. So thus far, again, I don't know if there's any actual Z problems here. It looks like most of this is fine. So I think that maybe it's just that corruption bug that we're seeing there. That seems like the main thing, and that could have been the cause of the second scene's error as well. So that's a good question. We don't know what's causing that. We really don't. So yeah, this all looks fine still. Nothing weird going on here. Mm, so that background is having it as well. You can see it looks like a striding error is actually what it looks like to me. And you can see the way those things are like shifted. So, there's different ways that could happen. One way is if the stride is just not getting set properly. I mean, that's obviously a possibility as well. But another one is if you're using memory that was written to with one stride and then you're not actually rewriting the thing that you thought you were. You can see there's some problem happening up here that could be the same problem, but I'm not 100% certain. So that one's harder to say. So I'm going to let it run through one more time. I want to see if these errors are the same each time or if they vary. And so you can see here we get a really different result this time through, right? So there's definitely some weird stuff going on. This seems to be able to trigger it much more reliably, probably because it's transferring large images and we're recycling those texture handles frequently, because there's only a few special texture handles. So you can see like all of this crazy stuff happening. So let's use this to debug that problem. I don't know that we really have any of the Z problems that it was originally saying we had, but we do have a problem, which is that texture transfer problem we were seeing in the regular game as well. So this is obvious. You can see it's totally different this time too, right? So let's figure out what's going on there because we don't really know. And we needed to debug this for the main game anyway, so this is all like really useful work. Okay, so one thing I would like to do is I think it would be nice to do this under Nsight, maybe at some point to see if it's got any messages for us, warnings, anything that it notices is wrong, because it may be that we're just not paying attention to something that we should be. There may be actually the graphics card, or the driver I should say, may actually be telling us at some point, hey, you screwed up, and we maybe don't know. So I'm not sure one way or the other if there's some other things going on in there. So we may want to check that out. First, what I'm going to do is I'm just going to refamiliarize myself with the basic texture transfer code. And I'm just going to try to verify that there's nothing out of hand going on there. Like nothing that I see that jumps out at me first. Because before I just go randomly investigating the code, I want to do just a spot check. So if we start, one of the nice things that we kind of know now, and we didn't necessarily know before, is if you look at where we specified GL text image, and let me grab that here because we're not there yet. Here we are. So where we specified GL text image, you can see us specifying GL text sum image 2D and GL text image 3D here. What's interesting is we saw this bug on both paths. And I think that's really interesting because that lets us know that we probably don't have a problem with like some specific use of, say, our texture array. If this path were always working properly, and remember what the difference between these two paths is, anything that can fit in our texture array, we just stick in there. But anything that's an oddly sized image, such as one of these big cutscene plates, it uses a special texture submission. And the really interesting thing about that is that means that this call can't really itself be the problem. Now, that doesn't mean we don't have a problem with the transfer. We still might. And the reason that we might have a problem with the transfer is because there's text transfer stuff that affects how memory is read and used. So it's not a given that it's correct in its entirety. But what is true is we're seeing the bug on both text image 3D and text sub image 3D. So we kind of know that we're not having a problem with a specific internal of one of those calls. It's something that's erroneous on both, right? On both paths. Now, I'm not sure specifically why we decided to do GL Text Image 3D here for this default sprite texture format thing. I guess we just decided that's the easier way to go. Now, one thing that we should probably have been checking here is to make sure that the max width and height of these things comports with the size of the textures that we allocate in the first place, because I don't necessarily know that we ever did that. And we may have had some textures that actually don't fit in here. Our modern import path would have fixed that by resizing them, but right now we don't go through that path for these. These are imported from old HHAs. So that might actually be one of our problems. It's not our only problem, almost certainly, but it definitely could be one of them. So we probably want to take a look and see what's going on there. So let me go ahead and check what's going on there. We have some hard-coded constants here. We just said this is our maximum. We're not going to use any other sizes than this. I can't remember exactly where I actually put that. It's sort of a max size. Where does that go? Where does that go? Let's take a look. Let's take a look. So we have the texture transfer buffer size, but where's our actual texture dimensions? You know what I can do here? Let me just search for 512 since I know what that is. So you can see here, there's our texture array dimension. But let me see here. So when we create these, so there's some things about this. There's actually some things here that don't necessarily line up with what I would expect. So for starters, when we're doing special texture handles, that shouldn't be sent down. That doesn't make a lot of sense. Does it? I guess we just never actually send down one of these dimensions early on. Because look at how we're doing this. This doesn't make any sense to me at all. Am I missing something here? So here's our path for generating our 3D texture here, right? That we use for all of our sprites. And then we come down here and we say, well, we would like to make some special textures here. And so we're going to allocate a bunch of those, but we allocate them as 2D texture arrays for some reason, which doesn't really make any sense, does it? Because I thought the way that we were rendering these is that we switch textures every time. So like I thought, and maybe this is totally wrong, but I thought those should have been regular textures, not array textures. And I don't really understand. So like you can see here, we do a GL texture 2D array bind of the texture handle. Why are we doing that? What is the point of that? I guess so you know what? I guess that's so the shader works. And we just only ever specify the base. Well, I guess there's nothing wrong with that. So I guess there's no real reason to think that that's a problem, I suppose. Although I guess I don't know that for sure. It is coming back to me now. When we did that, we didn't want to have two different shaders, so we just made it so that we use a texture array that's only one deep for all of these. So that all seems fine, though. Like, again, doesn't really seem like it would be a problem. It should still work. So that, I don't know. I'm not seeing why any of that would particularly be problematic. However, like I was saying before, one of the things that we did not do here is we have a text transfer, like there's transfer parameters that are in effect here, where we do, and it looks like we never actually set any of these. But if you look at how OpenGL works, when you call text image, any of those text image calls, like text subimage, for example, like we're calling to transfer the sprites, or text image 3D, like we're calling to transfer the main one. If you look at the documentation for it, when you actually execute this transfer, it should in here, it should in here tell us this, although I don't know if it actually does, that it uses the texture transfer modes that have been set in order to figure out how to copy. You know what I mean? And let's see. Yeah, the pixel store mode affects texture images, data blah 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 to visualize texture memory. Not seeing. Let me see. So pixel store modes, and yes, you can see all these pixel store modes in here. All of these texture transfer modes are relevant to us. So all of these things like pack row length and pack image height and skip rows and skip pixels and all that stuff. This is all going to actually affect our ability to transfer a texture. And I guess I don't know if that can be causing us some problems. The reason I don't think that's the case is I don't think we would be seeing it be intermittent. Like, it should always be wrong if this was wrong. And so I'm assuming this isn't the problem. But I just wanted to point out that it's there, right? And I guess I'll double check to make sure. So I don't know like what the defaults are for some of these, but like for example, it could, pack alignment could technically hurt us, right? Because if it realigned rows every time, then depending on the initial pointer alignment, that could shift us off, and it would change the size as well. I don't see any others here really, but that pack alignment, I'm curious what this value, is, the GL pack alignment default. Oops. I'm not sure what the default is. The default is 4. So again, can't really see how that could really be a problem though. If it was 8, maybe. But since our pixels are always 4 wide, I mean, it doesn't seem like we could really get that to be wrong. But I don't know. So I don't know. That's the only basic thing I could think of there where I'm just thinking maybe we could have something happen weird. But yeah, not a lot else. That's the only thing that seems particularly like suspicious in there, but it doesn't seem likely to me, honestly. We'll check it. But I don't think that's going to be it. So just based on that, I would say we probably are going to have to start doing some instrumentation here. So the first thing that I want to do is I want to try and get some idea of what's actually coming down the pipe on this. And so when I hit this GL text image 3D call, what I'd like to be able to do is figure out whether I'm sending down bad data or not as far as I know, right? So when, and in this case, this is the one that we normally call during the game, but we've got a good repro case here where this one seems to fail fairly soon. I don't know how many times I can get that to fail, or rather, I don't know how reliable the failure is. But it seemed like at least as you let it play on, it got more and more reliable as time went on, so that's something. But basically, when we're watching this, I'm assuming that I'll be able to get that failure to happen relatively soon. So what I'm wondering is, can I, when I come through here, can I maybe dump out the data really quickly or do something else along those lines where I can see whether or not the thing I'm sending down is corrupt or not. Like, you see how it's correct this time through, for example, right? So I have no idea what's going on there, right? So another thing that I think maybe could have some relevance, I'm not sure, is I don't know what would happen if we tried to render with the corrupt texture, with a texture handle that hadn't been filled yet. My assumption is it would just render, I assumed it would only render garbage for that frame, but once the texture handle actually got filled in, I would assume that it would start working again. I don't necessarily know that that's true. So I could believe that actually there was something going on there weird as well. And so we should probably check that too. One of the things you can see here is we didn't actually have that same corruption on the second sprite. So I'm going to see what happens on Krampus now. Wait for it. Yeah, so you can see that all of that seems to be working correctly. And again, what that sort of suggests to me is that maybe there was a problem with when we... Oh, you can see some of it up there, right? Some bugginess up there. Maybe there's just a problem with load speed. So if you're loading cold, if you're likely to be late, that could affect it. I don't know. Still having trouble coming up with a reason. I'm still having trouble coming up with a good explanation. It's a tough call. All right, so a bunch of things to check. Nothing seems particularly likely. I'm going to go ahead and run this under Nsight as well, just to see whether I get any warnings that maybe it would give me that it wasn't going to give me in the other case. You know what I mean? So I'm just going to set this up to run here. I believe our working directory is not handmade/data anymore, right? Our working directory, we decided, was different. It's just handmade, right? So let me go ahead and get that clipped off. And can I save this? Or is that not... I don't know if I can save this, but we'll just see what happens. So we're launching in the debugger here, and we'll just see what's up. There's output messages here, right? And we can see whether there's anything... Ooh. Not sure why that is saying that's... log is unavailable. It's not what I would have preferred. There we go. So I'm not seeing any texture weirdness here. So again, yeah, not really seeing anything, and don't have a really strong idea of where to look first. So we're gonna have to just wait a little bit here, verify that it doesn't have anything interesting to say to us, and then we're gonna have to start going in and instrumenting to find out what's going wrong there. And yeah, like again, shouldn't be too bad. It's gonna take a little bit of code because we need some way to inspect what's happening in that actual instance where we go to do the transfer. And so we can see whether or not something bizarre is happening. It'd be cool if you had something like an AI debug assistant that sat there and was like, oh, I see that this texture looks weird. It doesn't look like the kind of thing you would load. And you're like, all right. Again, don't see any buggy texture. Oh. Maybe, well, not necessarily. That might actually just be where that is. I still don't see any obvious bugs. There we go. So you can see here, I don't know if I can pause this to like capture for live analysis. If we just grab this particular frame, we can also go ahead and see what's up. I'm assuming though that there's nothing particular to learn here, because I'm assuming that what we will see is just the textures themselves are garbagey, right? At least that's my assumption. So if I go find, what textures are being used, I'll find that some are just kind of filled with garbage. So let's take a look inside our texture pool here. So here's all our textures. And I guess just looking through which ones are loaded, that seems fine. These are from the previous frame. I'm not sure which kind these are supposed to be. Available revisions. This looks like a target buffer, but this is presumably the actual buffer. Let's step through the drawing and see what we're actually looking at. So here's us drawing, we're gonna draw like the depth passes on this thing, right? You can see those getting drawn in there. So I'm not sure which of these actually produces the garbage. What's interesting about it is that at the beginning here, you can actually see that the depth buffer is filled with garbage, which doesn't make a whole lot of sense. Although I guess that's just because the thing that wrote into it before was that garbage. So it looks like this is our culprit here. This is an actual texture 20, that's just garbage, and this is what we're using to write with. So this should have been something, and it isn't. And looking at, you can see that it was something smaller that looks like it got smeared out here. And I'm curious to know, I don't know if this thing is able to view this in a different way. It's probably not. But I was thinking if I could get it to use different strides here, so that I could dial in a stride to see what this actually looks like. But I think I can make an educated guess, because if you look at what this shape is, you can see the olive green here. You can see a little bit of the whites of the eyes. It looks like this is just this, So again, if I had to guess, it seems like somehow maybe the texture transfer memory for this guy, which was right, got reused for this guy who's a different dimension. Do you know what I'm saying to you? And so this was supposed to be some other image, but really what ended up happening is it used this actual buffer when it went to reuse the text for texture transfer, and transferred a totally erroneous thing. So here's some stuff that I could guess about. If we were not properly reserving our texture transfer buffers so that more than one person writes into a texture transfer buffer, I say, okay, here's the 10 textures we needed to transfer, start transferring them. And person A transfers into buffer A, person B transfers into buffer B, person C transfers into buffer A, overwriting what was supposed to be there, stuff like that, right? So I want to look at that first because it smells bad to me. I just feel like there might be something there, and since I don't have anything else to go on, I'm just going to start looking at the place that I think is the most likely culprit first, just to maximize my chances of finding it and save the most time. You can only go on what you have to go on, if that makes sense. All right. So if I look in here, if you remember what happens, in load asset work, we try to do this read. And the read targets a particular destination buffer. And then it tries to transfer the texture, which happens here. And then it does its like end work, right? And so all of that happens inside this texture queue thing, which is actually something that lives in the graphics card side, which is like an op, you know, has some memory that it uses for the transfer. So you can see that here, and you can see here we've got a data pointer, and this texture op just moves, it rolls through those data pointers. This transfer memory that's here is what gets used for these texture ops. And so the thing that I'm thinking is, you know, I probably just screwed that up. I mean, it worked the first time, and if I remember correctly when we did it, not first time maybe, but like right away, we've probably got some subtle bugs there that just we haven't actually, like, we're not doing it right. You know what I'm saying? And so what ends up happening is we use some memory that we didn't really have, that was still supposed to be committed to somebody else, and that's where the error is coming into play, right? So I'm going to go ahead and suggest that we look there first. When we actually do those texture transfer ops, you can see here the way that we do it. When we call begin texture transfer, when we call begin texture op, we look through and we say, look, let's make, for whatever the size is requested, let's see if we can use that much memory, continuous or wraparound, right? And you know, this is another good example. What if maybe like our wraparound case is the problem? You know what I mean? Like what if one of these cases only happens every so often and like it set up some pointer incorrectly or something like this, right? That would be another good example, right, of the kind of thing that might get screwed up. Yeah. All right, so anyway, let's walk through that. So when we come through here, we get an op. We say, how much did we actually need? So here's the size we actually need, width times height times 4, right? And then we say, look, how much do we have? And we assume that we start with nothing, and let's try to find it. We say, first, we're going to look at whatever the, you know, the sort of memory arena area we're using is. We're going to say, here's the first used byte in this block of memory using for transfers. And here's the number of bytes that we're currently using, okay? And so there we say, if at that point we're over the edge of the memory, then that means that we actually start back somewhere at the beginning. So this wraps the pointer effectively and starts us back sort of before that first used byte. And so the size that's available is just however much memory there is between where we are and where the, excuse me. Yeah, where we are and where that first used byte was, right? In the other case, where the used space is contiguous inside the region, doesn't wrap around, we have to check both the overhanging part and the beginning part. So we say, all right, first let's say that we just subtract memory from transfer memory count to say how much is there between the where I am in the buffer and the end. If that's enough, then we don't need to do this case. If it's not enough, then try the one that starts at the beginning. So set memory add equal to 0 and set size available equal to sort of that difference between 0 and the first byte that was used. Once we have that done, we say, is the amount we requested going to fit in the biggest chunk we found, right? Or not necessarily the biggest, but we would look for a bigger chunk if we knew that we needed one, right? So we looked for the one that would be most likely to fit. And we said, can we fit it? If so, we get an op out, we take wherever that location was, and we put that in there. We set up everything so that the last used stuff works okay.
So, you know, one thing I would say, I would caution one thing, and that is if memory at was right on the border, is it okay here?
We would subtract back. So that's okay. Um, so then we would say, yeah, this is where we're going to write to. This is how much we're going to write. And then the place you need to restore to is going to be this size requested, right? So that's how we would move the first used forward. And that all looks pretty good. And at that point, we would say, oh, by the way, we used that much more memory.
Now, you know,
There is something wrong with this, though. And I think I can see this may actually just be the cause of our bug. In fact, just walking through it there, I think I can sort of see the problem, actually.
and the problem is that the memory used count.
If we're only increasing it by the size that we requested, then this wrap operation the next time through will fail to produce the actual end if the path we hit was this one. Because we have failed to take into account this additional piece of memory. Right? I don't know if everyone out there gets what I'm saying. And we could go, if you want, let me draw it for you. Just in case, I don't want anyone, especially any beginners out there who've been trying to follow along with the series, I don't want them to get confused about what I'm talking about here. And when I moved, I failed to plug in my Wacom tablet, so we're going to just plug it in right now and hope that it works. What could possibly go wrong, you know? Sure, it'll be fine. There we go. All right. So if I go ahead and open up Mischief here, yeah, we're fine. Good job, Mischief, by the way. I'm not Mischief. This is not Mischief. This is actually Milton. We switched from Mischief. I forgot. Long ago. So what I'm talking about here is we've got this buffer. And there's a couple different cases that we're working with. I'll draw all three of them out so that you can just think about them, and then I'll show you why I think there's a bug. So we record two pieces of information. We record essentially a start and a size. The start tells us where in the buffer to begin in terms of, and this is for what's used. So to figure out what's used in the buffer, we record a start and a size. So the start says, well, this is used. And then the size tells from there how much is used. So one case is this falls inside here. Another case involves that same thing. And then there's a case where it actually looks like this. And of course, you can't use space off the end of the buffer. So really what it's saying is it comes back around this way, right? So it wraps. Okay. Now, in the wrapping case, we don't have a problem because there's only one way to use this chunk of memory, and it's to start here and use as much as you can, right? And in the case where the thing we're trying to fit happens to fit in the end of the buffer, in this case, we also don't have a problem. So case C, totally fine. Case A, totally fine, because the thing we got to put just fits right in here, and this is our new space that we used, and everything's fine, right? What I'm suggesting is the problem becomes when we have something where the thing will fit at the beginning but not at the end, okay? So let's pretend that this buffer was shorter, right? Like it's that long or something, right? So, you know, if something fits at the end of that, then we're good to go, right? So if it fits in here, that's totally fine. what we would say is the memory at would be here, the size would go to there, and we would then record that as the place that we would restore ourselves to, right? And we would set the used size now to be that by adding this much to it. But now, in this case, let's say we had something that wasn't going to fit. We would look here and say, oh, it does fit. It fits over here, right? So then we would set, oh, the last used is going to be here. The start still remains here, but then, oh, how much space is used? Well, it's going to be this much was already used. We're adding this much there, so it's that much, right? But we didn't use that much. We used that much plus this much because we skipped this part of the buffer. So in order to get back to here, we would actually need to include this much, because otherwise what will happen is when we then go to compute how much is used, we'll miss and we'll say that we could actually start here, right? So by forgetting, and just to draw it one more time, we start here and we say this much is used. And I guess I need to draw that differently. We start here and we say this much is used, right? Now we want to place this much in there. Well, what we were doing is we were saying, okay, the new amount that's used is that much. If you actually wrapped that much, you would use only that much. But we're actually starting here to place it contiguously, so we're actually using this much because this much here was skipped. And that skip amount has to be counted in order to get to the correct place. Otherwise, when we actually write this thing in, the next person will overwrite the beginning of our buffer. You see what I'm saying? I hope that makes some sense. It probably doesn't, but if you were inside my head, you would know what I meant. Hopefully that just shows you a little bit of it. Okay, so looking at how this is working, what that means is in here where we do transfer memory and we get that size, we get that size going. I wonder if maybe the correct thing to do is to not use transfer memory transfer memory used count thing. Like, what if we just use a transfer memory like first used and transfer memory last used? You know what I mean? What if we just did that, and then every time when we do the result, we would use that used thing up. That's one thing we could do. A different thing we could do, and you know what? I think that would simplify this code too, because remember when you actually do an end texture op, or complete when we do this complete transfer op, right? That's then gonna kick it back to the OpenGL side of things. And when it does this, you can see what's going on here. It modifies these two variables. And when it modifies those two variables, it's actually doing like a decrement there, and also setting this first use. But really, we should be able to get away with just doing that, right? We should be able to get away with just using that. And so I think I'm encouraged to maybe do that, and we can simplify this down. The size would no longer have to be included. And so inside that texture op too, if I went back here, I think this could actually be removed. So it would simplify as well that part of the process too. And so then what we would say is, well, in here, we would do a first used and a last used. And those would just kind of move along, right? So I think that's right. We could do that. Now, there's a reason I didn't do that originally. The reason I didn't do that originally was because I didn't want to have to figure out how to deal with the case where they were equal, right? And the problem with that is in the case where they are equal, I wouldn't know whether all the memory was used or none of the memory was used. Does that make sense? But I actually can disambiguate that And the reason is because it just depends whether or not there are any ops, I suppose, would tell me, right? If there are no ops outstanding, then I know that nothing is used. And if there are ops outstanding, I know that everything has been used. Might be another way to, right, would be another way to say that. And so I think that would be fine and would always work. I don't know. We'll find out in a second as I go destroy this piece of code. So if I do this and then I just clean up my errors, that will force me to write the stuff that needs to get written to make this happen. So in here, if I set that last used and first used, and then I come through here, you can see this transfer use memory count. This part of the logic will have to get rewritten, and that's fine. This goes away, and this part will be an update of the last used code and that stuff. But I think mostly just looking at where this is happening, I think we're just totally fine. Okay, so coming through here, we look at memory at, and what I want to do is say, well, memory at now, I always know where it is. Memory at is always transfer memory last used, right? Because that is moving all the way, that's always moving forward to give me like my last byte that I was using was just before that. So this memory at, that's just the value right there. I don't have to do anything to condition it, right? So now what I need to know is, well, okay, does this thing, is the space that's being used wrapping around or isn't it? Well, it's actually pretty easy to tell because if this pointer is before the first used, then it is, right? So what I want to do here is say, okay, the use space wraps around is this case. All I have to do is say if memory at, I don't even need memory at, to be honest. I can really just do it like this. If transfer memory last used is less than transfer memory first used. So if the last pointer comes before the first pointer, then I know I wrapped around. And so that's really all I need to do, right? Now memory at in this case is again going to start here. And when I know that the space wraps around, I don't have to do this anymore because I'm not computing on a wrapped buffer. So this is always correct now in this case. And then the size available is still going to be computed exactly the same way. It's just going to be the difference between these two. Wherever I'm that last one using, it's going to go all the way to that first used. So that's really very straightforward, right? Now, I have to, again, be careful about handling the case where they both are equal. So if they are both equal, right now what I would do is I would fall into this case because last used will not be less than first used. And so we'll have to handle that here. What we could do also is say something like this. So in this case, the size available, it's really just going to be entirely conditioned upon whether or not there are any ops outstanding. So if there's an op count right now, then the size available is 0. So it's only if the op count is equal to 0, then I know that this is the case where actually all of the memory is now free. I can use all of it. So it makes it trivial for me to write in the amount because it's this entire size, right? I get everything. So that's an easy way to disambiguate those two cases. We know that this case is the same, and so we're really just down to this case where the use space doesn't wrap around. That means there's going to be two different usable spaces. This size available is still correct, right? And this one is still correct as well. So I think this still just works. I don't think we need to really change that case. I think it's still fine. And so then all of this stuff is good. It's just this now is not what we want to update anymore. What we want to do is get that last used pointer here and say that last used pointer is going to equal the place where we would have ended, right? So we're actually just using that computation that we did. We're just going to say, look, we just remember what that was. And so I think that's all good, and I don't think there's anything else we really have to do there. I don't know that this... I don't understand why this would have to be less. It feels like that's a less than or equal to me. And
I'm just trying to think through like what would happen if we ended up at the very end of the buffer. And so I think if we end up at the very end of the buffer, we would say that the used size was just 0 here, right? And then we would wrap to the beginning here, which is what we want. So I think that's still all okay. Now, don't quote me on that because, well, it might be wrong. And I don't want to be quoted as having said something wrong. Nobody likes that. It's just very unfortunate. So let's take a look at what we have now with our transfers. And we know that this was a pretty good case for forcing those transfers to go erroneously. Let's just hope that our luck continues, and this is going to be another case where it's forcing those transfers to be erroneous. Now, I don't know if it is or not, because again, we had no way of really forcing it to happen. So we just have to give it a chance to go wrong and see. This one looks correct to me, and so does this one. Seems pretty good. See how the next one goes. Krampus kicking through the door seems to be a little bit of a turning point for us sometimes, where we can get some more of those errors coming in here. Let's see how we're doing here. Here's Santa. Such a dick. God, Santa Claus is just the worst. So Krampus is coming to save the day here in a second. Let's see what's going on. We'll see if we fixed that that sort of corruption bug there. That all looks clean now, so I don't see any more of those artifacts. We're gonna keep running again. I'm gonna go through the whole thing. I want to see what happens when we wrap around and play again from the beginning too. So that's looking pretty good. Again, everything looks super clean there. Yeah. Yeah, this all is looking good now. I'm not seeing any of those weird artifacts. So, we can't really guarantee that we fixed it because we don't have a reliable repro. But it sure seems like that was the bug. And all of these are replaying well, so I don't also see any problems with the Z, which was the original reason we started looking at it as well. I'm not really seeing any issues there. So this all seems pretty good. Yeah. So I think we may have fixed the bug. I'm not seeing any other ones. That was definitely a bug. So, I mean, when I looked at that code, I was like, this is not correct. So we definitely fixed a bug. The question is, did we fix the bug? I don't know if we did or not.
But the entire thing plays back properly now, so it sure seems like that was also the bug we were seeing here. Let's let it wrap once. Just make sure that there wasn't some other funny business going on there. Let's make sure it can reload the first scene after going around once. But then I think we're probably okay, and we can move on. We can also say that there were no Z fighting problems there, so I don't think we have Z issues. Okay, so this is busted. So when we loop around once, this is busted, and this doesn't. So far, there's no corrupt textures on here. So that I don't know where that's coming from. So we may want to, I don't know what's going on here, right? This is all totally garbage. So we're not seeing any corruption, but it's like it's using the wrong textures. So I don't know if we have a texture recycling problem or what's happening here, but we've got to go figure out what's going on because this is all messed up. And we don't really have any idea why. So that's another one. All right, so we've got two separate bugs. One was the corruption bug. Looks like it's fixed. I'm not seeing any of that still, even in this kind of bizarro world that we're hitting here on the second loop through. So that seems to work, but we also seem to have some kind of a picking the incorrect texture issue. And so I here's what I'm guessing is happening there. I'm guessing when we do evict a special texture, we don't remember that we did. Because remember, the asset system doesn't have the texture handle eviction on there. So I bet that's really all that's happening. So I'm going to go into here and just say that I think this is okay. Let's double check just before we move on to fixing that asset bug. I want to look at this one more time. Also, looks like my signature got messed up there. Shot 6, 3, and 4 are both 3.0. So, because that still could be a bug that we're just not seeing. So let's look at shot 6 and just make sure. So I don't know what he meant by shot 6. I assume it was this one, but I don't really know. What I'm going to do is, since he says both are at 3.0F, I'm just going to look at 3.0F and see. So yeah, it looks like these two are. Both of these two here are.
That is the one where Krampus is handing the kid the thing, right?
I don't know what these two layers are. I'm gonna run this and go to that point probably, because I don't have any better idea about what I should be doing. And then I'll just... Is there any way I could skip right to that too? Because I probably can just skip right to that. So when we're doing update and render cutscene, you can see us doing the cutscene warm-up seconds. That's for pre-caching. And then we do the cutscene T advance bit there. So I think we could just advance that time manually by a bit. Although also, when does it actually wrap that value, or does it? How does it map it in there? It's been a long time since we've done this code, so I'm not sure. Yeah, so it looks like it just kind of folds that in to it. So I think if I wanted to, I could just start this at, a higher one. So that'd be 0, 1, 2, 3, 4, 5. So 6, that'd be 5, right? So if I wanted to, I could do that, I think. Am I wrong about that? Where I just start directly in that one, I think. See if that's true. Well, I was one off. So, yeah. Where's that code? So this is this scene, I believe. And now we're in this scene, I guess. So I think that's this one. So I guess I want to set that to 6. Let's try that again. Oh, look at us. I see. So these are actually correctly numbered. So I wasn't, that's why 5 didn't work, because it actually is numbered this way because there's a phantom shot included there. All right, so this will start directly on that one. And so what I want to do here is try switching these layers here to give them a different Z. So I'll just do that. Oops, that's probably not what I want. And we'll just see. I don't know if anything will happen. Oh, okay. So there is. We weren't. He was right. There was some tears that weren't in the shot before, right? So I guess we did need to do that. So I think that's all good. And now, again, I'd like to go through and take a look at that, that recycling situation there. So I think we can call that done. In the asset system, so when we talk about special textures, what you can see happening here, right, is the special texture handles, they just roll around, right? And so, like I said, since we don't have any notion of when these things actually get freed, the problem here is just going to be when you go to use one of these, if you've already loaded it once, and this is exactly what we see happening, so I'm pretty much positive this is the bug. If you've already loaded it once, then we don't know that we've unloaded it to make room for something else, right? So you just go on using that texture handle thinking that the thing's still in it, but there isn't anything in it. So what we need is we need a way to properly account for the fact that we have unloaded one of these textures. And so when we unload that texture, we need to mark the fact that we have unloaded the person who was using that texture. Now, in the case of the special textures, we can do that pretty easily because we can just keep a list of which assets we're using them. I don't know how we want to do this long term, but it's not that... Well, you know, maybe we should just talk about how we want to do it long term, because we also have to deal with that for this case as well. So when we look for texture handles, we need to free up texture handles. We could just make this whole thing work in a... so that we do handle them both the same way. And that might be a nicer way to do this. So... the problem that we have is we have a limited number of textures we can use because we only have a certain amount of texture space on the GPU, right? So our goal here is to figure out how to make sure that when we go to allocate a space for a new texture we're going to use, how do we make sure we put it in a place that's likely to be the least impactful to what's currently being drawn? So we don't want to use a texture handle that we're likely to need again real soon. So anything that we used on like the last frame we don't want to do, and anything that we used maybe very recently, we won't want to do, but anything we haven't used for a few frames seems like a good candidate, right? But the question is, how do we keep track of that? So the way that one way we could do this is every time we go to use an asset, we could put it to the front of some like recently used list, right? But that adds a ton of churn, and it ends up doing a bunch of writing that it's not clear we really ever needed to do. And so you know, a better way to do it might be to say, look, when we actually need to allocate textures, maybe we just go through at that point and look at who hasn't been used in a while. And that way we just do that sort once and we don't constantly do rewrites, right? That's one way we could do it. Since only one piece of code is actually going through this route at any given time, it does mean that for the most part, we could just say, well, the linked list approach does work pretty well, and it would just work here. So I don't know. The other way to do it would be let's just always do that churning. So if you look at the way we did it, when we call get bitmap, you can see us marking the last used generation here. But we could just, I think, if we wanted to churn, do that churn. I mean, I don't really see why we couldn't. Because nobody calls get bitmap on multiple threads. It's a single thread function. And so while you'd be constantly hitting like these values in memory, it seems like it's probably fine because those values are just always, they're going to be always in the cache pretty much. So I don't know. That does seem like it could be fine. So the way that would work is inside the, you know, inside the asset system here. In this, instead of last used generation, we wouldn't have that in there. All we would have is an asset pointer that's like, you know, next LRU. And then we would just keep a singly linked list. Or I guess it would have to be a doubly linked list, right? Because we need to remove and reinsert on each go round, right? Now, I'm trying to think if there's any way we should do that differently. I think it would probably be fine. So if we did it this way, then what we would need to have is there would need to be a sentinel at the front of the list, right? But other than that, I think we'd be fine. But we also could just write it like this. Like so. And that way, when we have the LRU link in here and we say, look, we want to have the LRU, the least recently used list, kept here. Inside the asset system itself, I could just make a thing which says, okay, you know, here's that LRU Sentinel. And it's not an entire asset. It's a fake asset, right? And it's the Sentinel. So we don't ever have to care about that part of it. And you can always get the asset back from the LRU this way, right? Now, since I want to do that casting, I suppose I want that at the top. I'm not sure about that one way or the other, but it's probably fine. So if I want to do that, I think we also had, can't quite remember, but in the shared code, didn't we have, or maybe it was in handmade.h. Yeah, so we had some like boilerplate for this, actually, right? Where you could just do a dlist insert here and be done with it, right? So I think that might also be, we could just reuse that code as well if we want to. Now, inside here, I think I may have typed that wrong. Did I type that? No, I typed it right. So all I would want to do here is remove it and then reinsert it. And I guess I'm not sure why there's no remove. but there isn't. There should be this, where I say, oh, get rid of this guy. So my next's previous pointer becomes mine. My previous next pointer becomes mine. And then technically we would want to make ourselves be circular. I don't really know that we care about that though. I don't think we do. It doesn't look like we do, because in here you can see us just, those get cold set. So that should be fine. So if we were to do that, I could just say, look, I want to do a dlist remove and then a dlist insert. And we can just insert, it doesn't matter which side we insert, really. We can insert as last or we can insert as first. And since we want to call this the least recently used list, I guess I'm going to say let's insert it as last, right? And so in here we would get rid of the last used generation stuff, and that used generation thing would just go away in its entirety. And so this just resumes using it the way that we were using it before. So that used generation, that goes away. Used generation, yeah. Good. So if I did it this way, then all I would have to do is actually provide the sentinel. And in this case, it's the pointer to the sentinel. And I can just remove this asset's... well, actually, remove doesn't even require that, I suppose. So you know what? I guess one thing that I do want to do, there is a good reason why I would want to keep this initialized that way. Because that way you could always remove something, even if it's not in a list. Removal just won't do anything, right? So setting the next and previous pointers to point to myself might be worth it, just so that I can always know that I call that again. So it's basically just calling this init code, right? So this is probably better, I would say. So in this case, I want to remove this asset from the LRU list if it's in it, and if it's not, that's fine too. So I'm going to remove the LRU link from there, and again, that's this struct right here. And then I want to insert it into the lists here. And then I'll just keep those chained. And that way I always know which one is the least recently used. Again, I worry that it's too much work because it's rewriting 4 pointers every time on both. So it's like 8 pointer writes instead of 1 dword write. And so it's, it's definitely like... But you know what, though? I do suppose you could eliminate some. It would only be 6, right? Because if you know that you're removing it to reinsert, then you only really actually need 6. So I don't really know what we want to do there long term. We'll have to see, but it's entirely possible that this is still just fine because of that's not an appreciable overhead. So it may just be better to do it this way because then we don't have to have a weird hunting process where we go through looking to see who has the lower generation numbers or that sort of thing. All right, so if we do that, then that means it's pretty easy for us to always get whoever the least recently used person is and just to pop them off that list. Now, unfortunately, we do have a bit of a conundrum here, though, because we don't necessarily know for any given asset whether it's on the special texture list or not, right? And so when we go to do like our loading of textures here, excuse me. Normally we call this dimensions require special texture. We don't have any way to do that here. We would have to actually do some work. Now, maybe we want to actually do that work. I don't know. But you can see why that adds extra complexity there. Now, one way we could do it is to just say, well, at the beginning, we'll spin through and ask everyone which one they're in, and then we'll put them in the proper place. We could do that, but feels kind of wrong. It seems more like what we would want to do is just check each time, right? Yeah. And really, I guess it's probably okay because this can be elided. Here's what I will say. This check can eventually be elided with the check done to determine if we need to switch to special texture mode. So I think this is okay. So if I was to do this, that would let me have both of these. So in here I could have the special LRU central or special texture and regular texture. You know what I'm saying? And so that seems good because I don't want to have both. I mean, I don't want to have them both together. So if we do it that way, then what we would want to do is just say, look, we insert it into whichever one we need to insert it into. We know the bitmap width and height because actually when we return one of these here, this HHA asset bitmap bit, right, that's going to have that info in it. So, you know, this right here is the same. So we can just do info dim, and be done. All right, so I think that would be mostly what we would need to use there. And again, the big issue there for me is that delist remove. It just really violates the clear to zero-ness of it because that's got to be initialized now. Whereas before we wouldn't have had to have done that. And I don't know how I feel about that. You know, maybe it's fine because when we load all these assets in, that has to happen anyway. But now, you know, now you're kind of getting into that ugly territory of constructor land that I hate, where everything has to have this defined initialization point, and it's just you're asking for trouble at that point, in my opinion. So again, I don't love that, and I think I might say instead, you know, maybe an if is just better there, you know? Um, like maybe the better thing to do in that case is just just do an if. Just that. You know what I'm saying too? And that way, when you remove it, you get something more like this, and then we would just clear those two. That feels better to me because now init to 0 works. So it's a little more confusing because it doesn't obey the standard for W-linked lists where you all unlinked people point to themselves. But I think I like this better because I really don't want to be in the business of having to make sure all of those links are initialized. That doesn't do it for me. So if I go from there, let's see here. I'm also wondering, can this stuff get moved? What's going on with the asset locking? Does anyone care about that anymore? Do we even have an operation lock? Who calls this? This is just dead code, right? We pulled all this stuff out. Right? Yeah. So my other question was, is there a way to just move this code out of here? Can I put this, maybe into, just into the asset system proper here? Does it really have to be, in there like that? I'm just curious. Because I would like those to not be in the H file for any particular reason, because I don't really know. Yeah. So there's our prefetches. Oops. And I think prefetching fonts is not really a thing, but okay. And this is the same. That would go into here as well. So yeah, I think that was just, again, like we haven't touched that code in a long time, but I think we're good now. Can live in here. So get bitmap, is that just not, was that not exposed in here? Let's take a look. Yeah. So these just need to be put in here so people can access them. And I don't think there's an immediate for load font anymore either, so I'm pretty sure that's just dead letter at this point. I think that's not a real thing. Yeah. So that should really be that. Okay. Yeah. So that keeps the list, but it doesn't actually do anything with it. So we're not quite done with that part of the process. So let's go ahead and put that in there as well. So what we want to do first when we actually create our asset system here, we're going to want to initialize those links, right? So I forget what those are called here. Yeah, it's like dlist init, yeah. And so for this dlist init thing, I want to do our special texture LRU Sentinel and our regular texture LRU Sentinel. I'm okay with initializing those to point in a circular fashion because that's free. We just do it when we initialize the asset system. I don't want every asset to have to be, there's tons of assets. I don't want them all to have to get touched in that way for no good reason. So we should just hopefully run the same as we used to run now, right? We shouldn't have any issues. And then the only question is, how do we now use that change to fix the loading problem we were seeing in the cutscene stuff? And the answer there is like, okay, now we just need to use those lists to be correct in how we apportion our textures. That's not actually that hard because you can see here when we go to load a bitmap, you can actually see when I do the texture handle assignment, this was just making nonsense code, right? It was just saying like, all right, I don't know, like do, give it the next one in the sequence or whatever, right? So all we really need to do is just replace this nonsense code with code that actually checks that LRU list, and we should be fine, right? So what we want to do here is say, have a call for acquiring one of these textures, and I probably want like a acquire regular texture handle, and acquire. I guess maybe I don't care though. You look at this. I suppose the code doesn't care. So I suppose in here I can really just do acquire texture handle. And it looks like this maybe would just want to do the check internal. So like, this seems right. And so, when I call acquire texture handle, I can pass the assets and the dimension, let's say, and it will just give me back the right thing. So then up here, if I have one of these, I guess it's a v2u, like so. I would need the assets. And then in here, when it comes through to figure out what to do about the texture handles, it can just say, all right, if I need a special texture handle, then I'll use one of those. If I need a regular texture handle, I'll use one of those. But what I'm going to do here is instead of allowing these to be assertions, I'm going to actually make it be a case where it just pulls something off the LRU. So it's still going to do this, because we do need to use new texture handles when we haven't used them yet, right? But in the case where we've run out, so we've used all the texture handles that we have, then I can do a reuse, right? And so what that involves is me taking an asset that was in use and basically nullifying it, right? I want to go in here and say, this asset that was in some state is now going to unload. It's going to be unloaded, right? So I'm going to, replace asset. I'm going to do something where I do like this asset goes to asset state unloaded. and the texture handle for that replaced asset becomes the result here. I'm going to call that result. So again, just giving out texture handles the exact same way, but now what we're going to do is when we run out, we reuse one. So we just slam that guy to unloaded, so he's not loaded anymore, can't be used. And we recycle the texture handle. Right? And that's it. Pretty basic. So same thing's going to happen here. What we want to do is in here, these are this should look like the exact same piece of code. It just should it should do this check first, right? So it should say if we've got any left to hand out, hand one out. Otherwise, steal it from somebody else. Right? And that's going to be the exact same thing that we were doing before. Now, this code to find the replacement asset is going to be different because it's going to look in the LRU differently for each one. But once it does find one, then that code would actually be the same. So we could almost say something like this. And then down in here, we could go, okay, if there's a replace asset, then we're going to do this little dance. Right? So we're basically saying, look, we'll do whatever we need to do differently for these two sets. When we figure out what's up, we may set a replacement asset. When we get down here, if we did that, then you need to unload that guy and do whatever it is that you're going to do and blah, blah, blah. Right? That all has to happen. Couple things. All right, so first things first. If this asset doesn't have a texture handle that's valid, then we really don't want to put it on the free list. And if it does have a texture handle that's valid, then it should be on the free list, presumably. So you probably want to do this. And you probably want to do this. I don't know how to make a null one of these. Is there a clear call? Right, I want to say that once you reuse it, we need to know that it's not usable anymore, and so it should look something like this. That's my story, and I'm sticking to it. Yeah. So that seems better. And this is actually going to get the index out of this texture handle, by the way. Oops. And the width and height are going to be recycled, right? So that all seems good. I don't see any issues with that, really. All right, so finally, to replace an asset, what we would want to do is assert that they're, that the list we would need to pull from has something on it, for starters. So the special texture LRU Sentinel, or the, and actually, now that I think about it, we really only need the Sentinel here. So this could actually be replace link, or rather replace sentinel. So we can even reuse all of this code. Because all we need to do here is just say, look, the sentinel in question is this one. So we either get the regular texture LRU Sentinel or the special texture LRU Sentinel, and then we're done. That's all we needed. And then all the rest of the code comes into this block here. So we say, if we need to replace the Sentinel, let's make sure that there's something in it, because otherwise, well, we can't get anything. And there always should be, because if we don't have any new texture handles to give out, there better be somebody on the LRU, right? Because someone's using those texture handles, so there has to be someone there. So assuming that there is, we will then use the delink remove call, right, to remove the first. So the replace sentinel next, that's the first one in the list. So delist remove would pull that guy off. You know what I'm saying? And once that's pulled off, then we can turn that into an asset, right? Because that just is an asset pointer. Should do this. Something like that. So that would pull one off the list, reuse this texture handle, and then we can go from there. Unfortunately, I still use the word texture handle there, which I didn't mean to. I meant results. But other than that, we're okay, I think. All right, so we don't have an isEmpty for that, so we should probably make one of those. And let's see. I could even do a delist isEmpty. Just because, hey, why not? And that's literally just this. Okay. I'm not sure I got the sense right on that one, by the way. It's empty if it's equal. That was backwards. Okay. Let's see. Missing before if. Delist remove. That all seems fine. What was it complaining about? Oh. That's all it's complaining about. And so I think that's all I really need to do. I think that will now properly recycle texture handles based on whichever one was the least recently used. And that's actually just 2U16. So I guess we want to do that, I guess. We don't have one of these? How are you supposed to make one of those? Strictly out of curiosity. Yeah, it looks like we don't have one of those. Why not? Well, I'm adding one. It's my code base. I can do whatever I want. Right? I mean, how are you going to stop me? I mean, I guess you could download the code and change it back, but that still doesn't stop me from doing it. So, yeah, in theory now we would reuse texture handles. We know in the game, because we never hit that assert, we know that in the limited amount of stuff that we're trying out in the game here, we haven't hit that limit. But it did look like we had that problem here in the actual, in the cutscene. Because when we wrap around, we had cycled through all those textures. So we know this will blow out the special texture limit, and it's reusing texture handles in there. And so this should give us a test of that system, and we should see it either succeed or fail to reuse a texture handle from the special texture list. We won't really know if we did the right thing on the regular texture list, but we'll get to that point in the game at some point too, where we can get some testing on that. Just, you know, by virtue of using enough art assets in the game. So far it looks reasonable anyway. So I'm pretty sure by now we would have actually blown out the number of special textures anyway, because there's not that many of them. So I think we actually are already reusing textures. I can verify that fact by just looking in here. Let's see. When we go to allocate that texture handle. So in here, I mean, this is going to be in release mode build, so, you know, it's a little squinky to be sure, but I'm guessing we come through this path. Okay, apparently we come through none of this. This must have gotten welded in, so it probably got welded in here, basically. So, you know, until someone actually tries to acquire a texture handle here, we'd have to look to see which path it goes down by looking at the assembly, but we could try that. So let's go in here, look at the disassembly, and let's see. So, yeah, we don't have a lot to go on here. All right. So I'm guessing these are the two texture counter increments. So I'm guessing if we skip both of those, we have reused the texture. And we did. So I believe this is the path right here where we would be pulling it off of the Sentinel and reusing it. So I think that's exactly what's going on right here. You can see it doing the linked list, in fact. So we are already reusing, and we seem to be reusing properly. So I think that's just all there is to it. So not only did we fix that bug, but we also now check that item off our list, which is texture handle reuse. And so that should be fine. And we're just doing it the same way we were doing it before when we had a more complex memory scheme. We're just keeping an LRU list. Can't promise it's the best way, but it works. And so, yeah, we can check two things off of our list today, which is pretty great, actually. Let me just make sure we can wrap, because we still don't really know if we did it 100% correctly. Like, this isn't very rigorous testing here, to say the least. So I would like to just verify that it can at least wrap around, because then we know that we've hit the case where people on the outside are trying to reuse the texture. And that's it's a separate issue in the code. So it could be that we didn't properly do everything we need to do to solve that case as well. So it's worth going through. Wait for it. Wait for it. Much better. So it looks like we're recycling properly. We're actually getting, right, like all of those textures. Those all got reloaded from disk. We should also be able to see, you know, if we look at our performance, we should actually see it hit the disk to get those assets every time. So each time before the switch, you can see the preload, and you know, you should actually see those spike. Unfortunately, it probably gets cached at some point, and so I don't know. Yeah, like we're probably not, if it's already in the disk cache, we're not going to really see it on there because it's sort of a write that would just, I mean, it's a read that would just get answered directly by the OS out of the disk cache. So there is that, but yeah, if we did like a cold boot, we could see it. So I think that's all good. I think that's just all done. So we closed out that issue. And we just ended up doing this one too. So what else we got? We don't have much time left, but we could look and see a couple of these other things here. I guess we could look at some of these. So let's see if there are some minor ones here. Let's just clean up those. So S32 from Z, the index needed to pass ignored instead of at. Okay, let me take a look at that call. Yeah, so you can see here, like, we're supposed to not be doing that. So we were supposed to pass this here, and I even set us up to do it, but it just was a typo, and we didn't do it. And so if someone had counted on this not advancing the at pointer, it would have broke. So that's just, yeah, correct. I mean, I think that's just strictly what it should have been, right? That way it'll move ignored and then not do it. So that was definitely a bug. We must just not have been using it in any way that actually ever caused the bug to manifest. But, you know, it might have bitten us later, so it's good to just kind of get it out of there while we can, even though it wasn't an issue. It could have become one. Let's look at the sign extension bug here. So this is in the, yeah, oh, okay, I see what you're saying here, yeah. This is actually fairly subtle, but it's a good point. So what's happening here is it's doing sign extended promotion of the 32-bit to 64-bit. This is very subtle. If you set the high bit, right, of a 32-bit value, then whenever that high bit is set, it's assumed that that thing, if you were doing signed arithmetic on it or whatever, it's assumed that that is negative, right? That's what that means. And so anytime that you have routines that work differently based on whether something's signed or unsigned, some things don't, right? Some things just work. Addition, for example, doesn't care whether you're adding signed or unsigned numbers. It produces the same result because that's why we use 2's complement as a representation for negative integers, is because you don't have to implement 2 different pieces of code, right? Or 2 different pieces of hardware, I should say. But if you set the high bit and then you do something that is sensitive to signed values, so it's going to do a different thing on a signed value, you could get into trouble. In this case, C is creating this value, and the C default rules create it as a signed value. So it's going to create it as basically negative the 2 billion or whatever, right? It's going to create it as like the highest negative number or whatever that it can, right? Because remember, all ones would be just -1, and a sign bit with all zeros is like the highest negative number. And so if we give C that value and say compare it to a 64-bit value, it's going to upconvert this from 32 bits to 64 bits. And when it does that, it will do it one of 2 ways. If it thinks the value is unsigned, it'll do an unsigned convert from 32 to 64, which will pad with zeros. That's what we wanted. So the top will be zeros. If instead it's a signed value, it will do sign extension, which replicates the high bit. So if the high bit's 0, it'll get zeros. If it's 1, it'll get ones. That's where this is coming from, right? It thinks it's signed. It's replicating that high bit. We didn't really want that. Now, it doesn't matter because there's no actual other params here. But like Peter Forrest says here, that's who reported this, if Microsoft did add more flags in the future that sit up in that high 64, our code would stop working properly, right? And you can see why that would be bad. So we don't want that. That was just a sign extension bug. That wasn't what we thought we were typing, right? We wanted to type this as an unsigned integer. So we wanted something more like this. Okay? So let's see if we can verify that this will be correct, right? I'm going to go into that code. Or try to anyway. And you can see there's really only one place that we do this here. But I'm going to set the breakpoint there, and I'm going to look for evidence of that sign extension. Now, I don't remember what this code is in. It's in keydown. So when I call keydown, I get in here, and if I look at the disassembly, what you can see is here's that and. It's anding with an immediate, and the immediate is this nasty bit right here, right? And you can see that sign extension going on right there. Exactly as Peter suggested. And so what we'd rather do is say, look, this is an unsigned value, my man. Don't sign extend it. And so that's what I'm going to try here. And then what we'll see, if I hit a key now and get back to this code, we'll see if that did the right thing. And let's see if it did. Okay, well, that's very interesting. So it chose to do that by making a shift right of the value. Okay. I mean, it's doing what we want, but that was surprising. So that's not necessarily, I guess that's just what it thought was the fast way to do that. All right, well, let's watch it work, right? Okay, so the first thing we're going to do is move up. This is presumably a pointer in here. Right, yeah. We're going to do some moving. All right, so we're going to shift RSI, which is this value here. And I'm assuming that's the L param. So I'm assuming that these are both the L params. I'm guessing. want to say. Yeah, of course it was. I want to know if that's the L-param. I'm assuming that's the L-param, so let's just assume it was. We're going to shift them down, and we're shifting them down right like... you see the hex there. We're shifting them down, and we're going to check them against 1. So instead of ANDing with a mask that had the bit we wanted, it's actually going to do the opposite. It's going to shift it down and then check it there. And you can see the way it chose to do that. It's actually makes a lot of sense. What it's doing is it's doing a 64-bit shift to shift it down on the main register. Then it's just doing the AND on the limited size register. So although RSI and EAX RSI and RAX are 64-bit, ESI is just the bottom 32 bits of it. So it knows that it doesn't have to worry about the rest of the stuff that may have happened there. It can just use the bottom 32, which I guess it could have used the large one. It must just not want to do that because it's faster to encode, I guess, this way. So in both cases, it chose to shift it down rather than shift 1 up, and I assume that just produced the shorter sequence, right? And an easier comp, I guess. And that's it. So I think we fixed that. All right. So that seems good. And of course, the keyboard code all works as well. So that's just something we want to make sure of there. And so we're basically out of time. Is there anything else really quick I wanted to look at? What is this? So I don't know where that is. Let's find out. Let's find out where that is. So that's debug light buffer text index. Debug light buffer text index. Yeah. I don't know what the debug light buffer text index is being used for these days. Yeah, I don't think this is stuff we want, so I think that is correct. He's correct that this should just not be in here. Because nobody ever sets that, so it's not like it's ever going to get called. So I think that can just come out of there. So that's not really something that was really an issue. That's just, I mean, we might as well remove it because why not? But yeah. What's the Windows open the game? Interesting. We probably won't be able to debug that one now. Oh, right. So this was a way that we could avoid OpenGL 4.2, and I think it's fine. It was really just that we didn't realize when we had originally written it that we had two different ways that the depth or the MIP count or something, the level, was specified differently. And so when we called GL text storage, that was why. And so we didn't really want to have to call GL text storage, but I believe it's this is the problem, right? You need to change argument values when changing it, right? The levels argument, which is 1, must be 0, right? And so this has to change. So I think if we did this, it fails, right? That's why we didn't do it. And so, if you do this, you just get nothing, right? It errors out. And so in theory, it's just because these are different parameters. They just, for some reason, OpenGL decided, might as well make it maximally confusing. And that does seem to work. So I think we can get that out of there. And that way, text storage is an updated call. So I could remove that from the system. Okay. So that gets rid of GL text storage 3D entirely, which avoids any dependencies on later versions of OpenGL, which we don't really want to do. All right. I think that's it. We'll go to Q&A now. So we got quite a few issues checked off today, at least 4. These are Handmade Ray. So we should do another one of these. Maybe we'll do one tomorrow. Wait, I thought I marked that as closed. Oops, I just forgot to close it. So, that's one for a time when we're going to start doing sound. And this might be more of an evolved one, but we could look at some of these other ones here, because these enhancements are different. We don't need to work on those. Those are for later. And Handmade Ray is for Handmade Ray. And so I think we would really just be doing Linux updates. Check out the full screen bug. Look at these two, and go from there. All right, let's go to Q&A. Or try to go to the Q&A anyway. QA. Does 4Coder support indenting of shader code yet? I guess I don't know. Alan isn't around by any chance, is he? So, I'm assuming what you're talking about is like, inside here we just had some, we just dumped some shaders like in there. And, 4Coder doesn't know that that's a shader, so it just thinks it's a string, so it doesn't indent it, right? I'm not sure how I think I said to Alan, maybe what you could do is define your own in your Handmade custom, define things here where if you use them as openings for strings, it would continue doing indentation inside, or something like that. But I don't know if anything like that has happened yet. I don't know. Obviously, if you copied it out to a separate file, it would just work. Personally, I've only least recently used caches. Have you ever used a LFU and has it worked well? LFU just sounds like something you say in chat. Like, LFU, man. Um, I don't think I know what that is, or I don't know what the acronym stands for. What does LFU stand for? Oh, least frequently used. I see. So you're talking about keeping track of how many times something's been used? So I guess what I would say is uh, I can't think of the reason why I would want that for something like textures. Um, because the problem is that just because you use something a lot doesn't mean you're going to use it again. And the reason for that is because, maybe I'm in this area and it's the graveyard area and the player's hopping around there for a long time, so all of these graveyard tiles are like really frequently used. But then as soon as I leave the graveyard, I'm never going to use those again till he comes back there, right? And so the fact that they got used a lot is really not that relevant because games tend to change what's in that hot set dramatically quickly, right? So I feel like a frequency based one would have to be for a different use case, maybe, unless I'm misunderstanding the idea. Um, I don't feel like that really works for gamey things as well. Uh, but I don't know. But so I'm just thinking of that just off the top of my head. It may be that's not what LFUs end up doing. I'm not sure. I have never used one. I didn't even know that acronym. But I have certainly only ever used LRUs for replacement schemes, if that makes sense. So, who knows? Is there a good... let's see. The cache is divided into two partitions called privileged and unprivileged partitions. The privileged partition can be defined as a protected partition. If content is highly popular, it is pushed into the privileged partition. Replacement of the privileged partition is done as follows. Least frequently, or LFRU, least frequently recently used, evicts content from the unprivileged partition, pushes content from privileged partition to unprivileged partition, and finally inserts new content into the privileged partition. In the above procedure, the LRU is used for the privileged partition, and an approximated LFU scheme is used for the unprivileged partition, hence the abbreviation LFRU. The basic idea is to filter out the locally popular contents with ALFU scheme and push the popular contents to one of the privileged partitions. Yeah, so I guess what I would say is that might be good. I would want to read up on that more. I'd want to see some analysis of how that worked, right? In practice, because it definitely adds a layer of complexity. So if you're not getting something good for that, which I'm really not sure you are in the case of a game. Because, you have to remember there's two different kinds of things you might be doing here. In a game, it's a little bit different than what they're doing for like a content delivery network. So in a content delivery network, there's no such thing as like the stuff that's being presented for this frame, right? Because a content delivery network is not trying to optimize the experience for one user. It's trying to optimize the experience across many, many users who are all looking at different things. In a game, we know that the things that need to be shown in this frame are the things. There's an exact set of things. So we know that the stuff at the top of the LRU that was most recently used, so the last things on the list, I guess, if they're getting added at the end, we know that those things are what was for this frame. And everything that was before that was stuff that wasn't used on this frame. So we know it's not actually necessary to keep that in the cache for right now, right? And so I don't know that you want this additional thing, which is like over time, I also kind of want to know that there's this set of things that tend to come up frequently, and just because I don't need to serve them to this user, I shouldn't evict them because the next user probably is going to ask for them. Maybe the game wants that because there's UI things or sounds that happen very regularly, but again, the fact that it got used a lot before doesn't mean that it's going to get used a lot now, which is probably the case in a CDN, I would guess. So I don't know. That's a tough one. It's a good question. I had not really thought about those other schemes much. And yeah, I guess what I would say is, so you're saying on there that LFU has more overhead than LRU, more accounting, but statistically it supposedly converged to the same expected values. Yeah, that's sort of what I was saying is like when confronted with a new thing like that, like a new eviction scheme, you kind of got to dig into it. Like it can't just read it and go, is that better or worse, right? So that's why I said I'd want to see more literature on it if people had done analyses. If they hadn't, I'd want to do my own, and just see what was up. But yeah. Any more on-topic questions? All right, well, since we have no more on-topic questions, I will mention one off-topic thing. We need custom emotes. And I'm not sure what those custom emotes should be, so we're going to make some. But we kind of need, like, we need to do that, right? Like, we need to figure out what those assets are going to be. And I don't remember how many there are. Let me see if I can see on here where that is. It's under like channel or something or partner or whatever it is. Yeah. So like loyalty badges and stuff are coming, and those are just going to be like what, they make sense. You're like, okay, these are loyalty badges that make sense. The emotes are whatever you want, right? So you can define your own codes, and we can make like 3 of them, and or 3 or 4 of them actually. 4 of them? I can't tell how many it's supposed to be. 5, 6. We can make probably more than we can think of. And so we need some ideas about what the emotes should be, right? Like Owl of Shame is probably going to be one of them, I would guess. And Piggy should be one of them. Yeah, Mint Spider, I agree with you. Owl of Shame and Pig Hat, for sure. I'll make a little, oops. I was about to send a mail to myself, but I typed on the wrong keyboard, so I just inserted it into my code instead. Send it to Casey. There we go. Emotes. So pig hat, owl of shame. What else? Go look at the Handmade Network Discord emotes. John Blow's face. We would have to pay like John Blow licensing fees. All right, that's the end of the scene. Well, anyway, be thinking about that. If you have ideas about what you want, a lemon grab. Can we do that though? I don't know if lemon grab is allowed. I mean, that's lemon grab. I don't know how, like, I don't even know what the copyright laws on stuff like that are. I don't even know how they work. Because I think that's kind of difficult territory. I don't know if anyone's sued for using their likeness as an emote or a cartoon character that they created as an emote. I don't know, like, what goes on there at all. So that's hard to say. Anyway. I'm going to wrap it up. Oops. Let's get that out of there. There we go. Okay. Thank you, everyone, for joining me for this on a Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along the series at home, you could always pre-order the game on handmadehero.org. And it comes with a source code so you can follow along with the series. I will probably be back for another stream. I'll probably sneak another one in there before winter break really begins. So I can't promise this is the last you'll see of me before Christmas. There might be another one tomorrow. So we'll see. Stay tuned. Until then, or till whenever we get back here, have fun coding. And I'll see everyone on the internet. Take it easy, everybody.